Section 5, Unit 4, Manual Lathe Threading. Introduction. Threading with a lathe offers control over fit, finish, and form. Important to understand thread calculations, how to properly set up and operate the machine, and how to measure threads. Screw thread terminology. You got your flank, helix, helix angle, crest clearance, root clearance, lead, length of engagement, right hand thread and left hand thread. And here's a diagram of all those defined. The major parts of a 60-degree V thread. The flanks are the surfaces where the two mating threads make actual contact. And there's your clearance. The clearance between the crest and the root of mating threads, there is no contact at this point, and this area does not determine fit between mating threads. So there's a single thread, or single lead thread, and a double lead thread. A double lead thread has much more steep helix angle than that of a single thread. The length of engagement determines how many threads will be engaged with the mating part. A right hand and left hand thread have opposite thread helix directions. Class of fit. Standard class of fit is defined to ensure consistent levels of tightness/looseness, determined by clearance between the mating thread flanks. Class 1 has the most loose fit, Class 2 has the medium fit, and Class 3 has the tightest fit. Letter A is external threads, and letter B is internal. Determining thread data. Data required for lathe thread cutting is major diameter, minor diameter, pitch diameter, and compound rest end feed. Producing threads on a lathe. Several successive depth cuts are taken along the diameter of the workpiece with a single point cutting tool. Feed the spindle rotation are timed so that the same thread groove is tracked on each cut. Tool infeed setting is performed with the compound rest at an angle. And the compound rest is set approximately 1/2 the included angle of the thread so that one cutting edge is dominant when removing material. Lathe setup. Setup, install workpiece, set quick change gearbox, set compound rest, set spindle speed, install and align cutting tool. A cutting thread chart affixed to the quick change gearbox shows the lever settings for cutting threads. The left half is the metric threads, with the numbers on the left showing the pitch in millimeters, and those on the right showing the machine lever settings. The right half of the chart is for English threads, with the left numbers showing TPI and the right numbers showing the lever settings. The graduations on the compound rest base are set to between 29 and 29.5 degrees for cutting 60-degree V threads. Spindle rotation, compound rest orientation, and feed direction are cutting external right-hand threads. Single rotation, compound rest, and feed direction for cutting external left-handed threads. Spindle rotation, compound rest, orientation, and feed direction for cutting internal right-hand threads. And spindle rotation, compound rest, orientation for feed direction for cutting internal left-hand threads. Various thread cutting tools for external threads. Various thread cutting tools for internal threads. A center gauge. Center gauge being used to align the V form of the cutting threading tool. Lathe threading operation. Operation, cutting tool reference, thread dial and half nut setup, thread tool infeed and positioning, and thread termination. The hand wheel micrometer collars are set to 0 when the tool is in contact with the diameter to be threaded. The lever used for engaging the half nuts during threading is that little one squared there. A split half nut assembly is used for carriage motion during threading by closing the two halves of the lead angle. And the half nut engagement points for given TPI values with a typical thread dial. Most of the time, even numbers can be, if it's a quarter 20, it's an even number. And it can be any graduation. An odd number, any number graduation or any unnumbered graduation. Once one option is selected, use only that option throughout the threading process. Any half number, 1 and 3 numbered graduations, or 2 and 4 numbered graduations, and use that one after you do the first one. Any other fractional number, any graduation, but once selected, use only that graduation through the threading process. The cross slide is set to 0, and the compound is advanced 1/10 or 1/1000 to 2/1000 for a trial cut. The threading dial must be watched closely so that the half nut lever is engaged at the appropriate time. The screw pitch gauge is used to verify the correct number of threads per inch being produced. And some threads extend all the way across the diameter, and the half nut lever may be disengaged when the cutting tool exits the cut. A thread relief groove serves as an area to disengage the half nut lever without causing damage to the thread or adjacent surfaces. The threading tool may be quickly retracted at the end of each pass to terminate the thread, resulting in a vanishing thread groove. In A on the left, the cross slide dial is set at 9 o'clock for easy tool retraction at the end of an external thread cutting pass, and B on the right, cross slide dial to 3 o'clock for easier retraction at the end of the internal threading pass. Thread measurement. Thread ring gauge and plug gauges, class of fit. Thread micrometer, measure pitch diameter. 3-wire method, measure pitch diameter. And optical comparator, measure visually magnify thread form. Checking an external thread with a go, no-go thread gauge. And checking an internal thread with a double end go, no-go thread plug gauge. A thread micrometer being used to measure the pitch diameter of an internal thread. 3 thread wires carefully placed in the thread groove can be measured with a micrometer to determine pitch diameter. A thread wire measuring set contains several sets of 3 matching wires, diameters. A table may be used to determine acceptable wire diameters for using the 3-wire method on a particular thread per inch. A chart from a thread wire measuring set shows which wire size to use for a given TPI. The far right column lists a value to add to the major diameter for the measurement over the wires. That result may only applies to the measurement over wires for the upper limit of a Class A thread. An optical comparator being used to project a magnified images of a thread for an inspection of its form. And an Acme thread is high strength, ideal for power transmission. A tapered pipe thread is taper designed for self-sealing or transferring gas and liquids in pipe connections. A buttress thread is an asymmetrical thread form, extremely high strength in one direction. Other thread forms. Lathe and milling machine lead screws are commonly made of Acme threads. A special gauge is used to size the flat on the tip of the Acme thread cutting tool and align the tool with the diameter to be threaded. A tapered pipe thread allows mating parts to wedge together, helping them to seal. A threading tool for cutting tapered pipe threads must be aligned by using a center gauge on the straight diameter and not the taper. The profile of a buttress thread and tool in feet angle. And that's the end.